All right. Hey, everybody. Today we are doing our phase 2 project guideline walkthrough. But before we start, I wanted to show you all, if y'all are on Slack and y'all have the Slack app, they actually recently did this thing. Hopefully you can see my Slack. Someone like signal to me if you can't. But on Slack now you have these nifty little bookmarks. So I think you have to get the latest Slack app update to get this. So yeah, pretty neat. All of the booking links, the playlist is here, the Zoom link is here, the homeroom has always been here. So yeah, I just thought that was neat, nice to share. If y'all are like working with a project partner, you can also do this in your DMs as well. So yeah, maybe you link to your repo, link to your, I don't know, link to any resources that you're using. Maybe you link for yourself the guidelines doc. Yeah, pretty nifty. I just thought that was a really nice new Slack feature. Okay, enough about that. Let me just reshare my screen again. Okay, here we go. So it's project week, technically next week. So tomorrow we're gonna finish up topic 20, which is the last topic for the phase. But I figured topic 20, you'll see tomorrow these are more like things that are good to have and good to add for the project. So I figured we might as well just walk through the project today so you have a better idea of what the project should be looking like. Also, another reminder, don't forget to do your vlogs. I will be checking through them tomorrow and also sometime next week, but good to get them in earlier rather than later. All right, so I linked the Google Doc over here, and here's our guideline. So before we get into any details, some notes on dates, where we've been sort of talking about the project throughout the week, but today I guess is our official intro date. I did put here that data cleaned and EDA should be today. If you've seen the provided data set and any of y'all who are using like non-provided data sets, not too much cleaning to do. So just do some quick EDA. I feel like that should not take up a lot of the project time this time around. And just some suggested dates for when to get these all done. Our presentation will be next Friday, so take note of that. You'll be presenting the project next Friday during our study group time. Now, the review period, you'll see that it starts on the 19th, and that's because you all have a cohort break week. So your cohort break week is between phases 2 and 3. And so the week of the 12th to the 16th, you're actually on cohort break. There will be no study groups, no one-on-ones. You should definitely take that break. I'm going to take a bit of a break too. So yeah, just so y'all know, that will be a break week. Now, during that week, you'll notice that you would have already presented your non-technical presentation the Friday before. The week after, you will be scheduling your individual project reviews. So maybe during that break week, you clean up your notebooks a little bit. I'll be talking about some of my expectations for the notebooks during one of the office hours next week as well. Any questions about dates at this moment? Cool. So just know that your review should be between the dates of 19 to 23rd. If you would like to get your review done earlier during the break week, you could. I will tell you that I've actually taken a few days off during that week. So if you find something on my calendar that works for you, I don't mind doing it either. But there are going to be limited time slots. So first come, first serve. All right. Okay, back to our guidelines. So we talked about sourcing data previously. Again, you should have told me by now if you want to work on a different data set that isn't the one provided. If you haven't yet, just let me know. I think I just really want to see what you're working on and also to make sure that it is a valid regression data set. Okay, so I'm going to explain this project through a notebook guideline or an example project workflow. Just through experience, I find that this might be the best way to explain all of these processes that we're going through. And if there's anything additional, I'll be taking notes. So this doc has had like a couple iterations from a bunch of different cohorts in the past. So to start, in your notebooks, you should have an introduction or an abstract. Why are you doing this project? For the housing data project, why is it important for you to be able to predict prices in Kings County? Good things to think about is you can think of it from an inferential standpoint or a predictive standpoint, right? I talked about the two goals of statistical learning theory are to make conclusions and draw conclusions and learn about your data and relationships between the features in your data. as well as to make predictions. So perhaps your business case has either of these elements or both. Both is also fine. So that's what you should start with. I think this is also something you can iterate on as you get your results. Maybe you think of something that you can add to your business case, you can definitely do that. All right. After setting up your business case at the top of your notebook, data cleaning and EDA. So there's not too much data cleaning to do, especially for the provided data set. I think there's just some null values to fill, some strange values that you have to figure out what to do with. And all of these data cleaning steps, I would say I've gotten a bunch of questions from a bunch of y'all being like, okay, what should I do with these numbers? And I think for those of you who have messaged me, most of my replies have been, it's up to you. It's up to you. How do you interpret the data, and how can you explain your decision? And how can you say that, how can you explain that what you're doing makes sense, especially in the context of your business case? So there are no rules for data cleaning. Just as long as you can justify what you're doing, you'll be good. So some things to guide your EDA, perhaps ask a couple questions about your data. You can maybe take an approach similar to the last project, but not as big of a scale. Maybe think about, okay, if my business case is to be like a real estate company who wants to make price predictions, what are some questions that I would have that I would like to see in EDA? I, for EDA, like to put myself in the shoes of whoever my non-technical audience is and think about, okay, just genuinely, what am I curious about with regards to this data set? Here is where I suggested that you can do some of your linearity, some of your assumption checks. So for example, a linearity assumption check, which features are highly correlated with the target. At this point, you can also take note of which features you might want to transform because maybe they don't immediately satisfy the linearity assumption. And also take note of collinear features for multicollinearity check. All right. As a bonus, you definitely do not have to do this if you don't feel like it. You could do statistical tests to enhance your EDA. A really good application of this would be an ANOVA test for your categorical variables. So an example is ANOVA test. If you remember, ANOVA basically tests for the difference of means between categorical variables. So let's just say that you have a categorical variable of, categorical variable of, let's say grade 1, 2, 3. I know there's a grade column there, I forget what that means, but let's say there's grade 1, 2, 3. What you can do is you can run an ANOVA test to see if the mean price is statistically significantly different between grades 1, 2, and 3. Run an ANOVA test on that. And if you get low p-values, then it's actually more likely that if you turn your grade into a categorical variable, they're more likely to be significant. So that's just something that you can decide to do, but completely optional. I'm not expecting to see like t-tests or ANOVA tests being set up in this project. And perhaps you also want to do some feature engineering. You can also choose to supplement your data with other data that you want to find. I know in the past, like some people have found like distance between zip code center and like, I don't know, school districts or something like that, or closest distance to city center, things like that. You can perhaps engineer some features at this stage if you'd like. So after this, like importing, cleaning data, EDA, you move into more of the traditional feature engineering. So yesterday we talked about get dummies for making categorical variables. One hot encoding we haven't talked about yet, but it does exactly the same thing. One hot encoding is basically the scikit-learn version of pandas get dummies. They're the same function. The syntax is slightly different, but they do essentially the same thing. So at this point, before you do your train test split, so remember yesterday I talked about train test split, make sure that your data is now in a format that can be fed into a model. Very important that you check that there are no null values and there are no non-numerical values as well. Now here I have this bolded statement and I want to talk about data leakage real quick. And data leakage has something to do with train test split, but before that, any questions about anything I've said so far? Okay, cool, awesome. So let's think about data leakage. Now, when we do a chain test split, why are we doing a chain test split? Chain test split is such that our model, so that we can basically test our model on unseen data, that 20% of our test set, we're going to see how well your model is able to predict on that test set, especially because the model has not seen any of these values in our test set, in our 20% test set. Now, data leakage is something that is important to keep track of. I would say in this project, I'm not going to be very like strict on like, oh, that's data leakage, that's data leakage, but something that's good to keep in mind. One scenario you can think of is, let's say you want to transform a variable. So let's say you have a variable that you want to min-max transform. And so let's say this variable has a min of 0, a max of 1000, and you min-max transform your data to be, instead of being between 0 and 1000, it becomes between 0 and 1. So the value that was 1000 is now at 1. That's what a min-max transformation does. If you were to do a chain test split on your data, what if that 1000 data point ends up in your test set? So data leakage, it's a very small data leakage, but technically this transformation, because you did this transformation prior to the chain test split, the data has been transformed with data from your test set. Hopefully that made sense. Ideally, what's going to happen is, let's say you do your chain test split first, and in your chain set, the min-max is now, instead of 0 to 1000, let's just say it happens to be 1 to 900. In your chain set is 1 to 900. So what you should actually do is min-max scale from 1 to 900 to 0 to 1000 versus all of them together. And you will end up with slightly different numbers. The difference is very, very subtle, but still technically data leakage. And also when you get to like bigger scale projects, it might have a greater implication. But did that make sense? Does anyone have any questions about that? Okay, that's something that I think like you have to like sit with for a little bit. Next phase, we'll talk much more in depth about data leakage. And in this project, you don't concern yourself with any of that, it's fine with me. Which is why here I say, don't do any transformations that have to do with the distribution of data before chain test split. So doing that min-max scale, the fact that your min-max scale will be different between only doing it on your chain set versus doing it on your entire data set. Now to contrast, a transformation that doesn't have to do with your distribution of data is something like log transform. So log transform, you're just taking the log of each data point. That transformation is not affected by your distribution of your data. So for log transform, technically, it doesn't matter if you do it before or after, because the numbers will all be exactly the same. If you're dividing all of your data by 2, or like, let's say you're going from a percentage to like a decimal number, dividing it by 100, not going to affect your chain test split and not going to cause data leakage. But if you're doing things like a min-max scalar, if you're doing a standardization, like taking the z-score, because the mean and standard deviation of your data could change depending on if you're looking at your full data set or just your chain set, that's some data leakage. We'll talk a lot more about data leakage and like instances in which you want to look out for that next time. If you want to get even more nitpicky, I guess I should mention as well. Let's say you're filling in some null values and you're filling in your null values with like the mean. Technically, that could also be data leakage, because the mean of your data can change depending on whether you're looking at just your chain set or your entire data set. So some people who are extra careful about data leakage will actually do chain test split at the very, very beginning of the project, and then just take note of what transformations or what data cleaning you're doing and replicate the same data cleaning onto your test set. So for example, let's just say that you have a bunch of null values in the basement square foot column, a lot of null values there. And you want to fill it in with the mean, which is, I don't know, 300. The mean is 300 for your entire data set. However, if you just look at your chain set, your mean is 250, for example. So the idea here to prevent data leakage is, instead of filling everything with 300, you're going to fill the chain set with 250 and the test set also with 250, even though the mean of your test set might not be 250. You want to transform your test set with parameters of your chain set as well. if that doesn't make sense, we're definitely going to go over this in much more detail, and we're going to see a lot more examples of this at the beginning of next phase. So not to worry about that too much for now, but I just want to like put it in your head, like when is data leakage happening, and something to think about. All right. So,
sorry, just to clarify. So should we
yeah,
be doing the train test split in the beginning? Is that like standard practice?
that is actually very standard practice to do it at the beginning. I would say for this project, I'm not going to be very like nitpicky on where you do it. In a lot of projects, the train test split technically happens in between, like within the data cleaning stage. Basically, whenever you get to some data cleaning that is that has to do with distribution of your data, then you do that after your train test split. The only difficult thing is you would then have to keep track of everything that you're doing. Like, for example, you have to keep track of like the means that you're imputing into null values. You might also have to keep track of like the min max when you do your transformation. So because of that, it is very difficult to keep track of all these things. And only next phase will we talk about the more standard way to do it. So therefore, for this project, I'm not going to fuss over where you do the train test split.
Okay, thank you.
But just good to think about, good to keep in mind. All right. Okay, so after train test split, I would say good to start your modeling. And the modeling is going to be very, very iterative. I think I've said this a bunch. The modeling is going to be very iterative. You're going to run at least like 10 plus linear regressions. You might not keep all of them, but I'm very sure that all of you, each of you are going to run like 10 plus different models, just with like different subsets of features, different transformations, so on and so forth. So how does one way that you can track your model's improvement is starting with a baseline model. There are a couple of reasons for using a baseline model. First, it gives you a baseline of like where your starting point is, and the idea is to just improve from there. So start with your baseline model. I do recommend using stats models. You can use scikit-learn as well if you like, but scikit-learn just doesn't have that nice output. So I do recommend using stats models, and keep track of your R squared and your RMSE. I'm not going to say and or, I would say and your RMSE. Reasons for baseline model: 1, to track an improvement. 2, at the very end, when you're evaluating your final model, you usually will improve your model by a good bit, either through R squared or through RMSE. Now, for job search purposes and for your resume, that's a really good metric to keep track of. If anyone's familiar with like the process of like putting together a resume, people like to see numbers or quantified, just quantified things on your resume, I guess. And so let's say you improve your RMSE from like 0.6 to 0.8. That's a solid like 30% increase in your RMSE or R squared. And that's something that you would put on your resume, like improved R squared of a linear regression model through iterative modeling by 30%. That's something that you're going to want to keep track of. So that's why I say start with like a not so good model so that you can learn from it, and also you can keep track of these metrics, and also you can put that on your resume, that improvement. Okay, so with your baseline model, how many significant p-values are there? Maybe look at some coefficients right off the bat, keep track of your metrics again, and yeah, from there it's just going to be iterative modeling. There's a lot of different things that you can be doing. And I want to see at least 4 models in total in your final notebook that y'all put together. I'm very sure that y'all are going to be trying way more models than these. But I would say with each model, whenever you have something that is a significant change, keep that model or keep that output in your notebook. So for example, let's say your first step, you want to drop all insignificant p-values. When you do that, likely, because when you drop, let's say you drop 5 insignificant p-values, more might come up later. You're going to be doing that a couple times. I would say in your notebook, it's good to show maybe like the first one and the last one to see the improvement between there. So overall, at least 4 models that you're trying different things. So out of the things that you can try, you can remove your correlated features, remove high p-values, maybe you do some transformations and some scaling. And then this is what we'll talk about tomorrow in topic 20, interaction variables and polynomial variables as well. So for each of these models, especially the main models that you're going to keep in your notebook, interpret your p-values, your r-squared, and your coefficients and RMSE. Are your results improving? Are there any drastic changes in the significance of your variables, and do your coefficients make sense or not? For those of you doing the housing data set, there's probably going to be an inferential component to your business case. Like for example, if you are trying to figure out, okay, what's the best number of, I don't know, what's the most value number of bedrooms to go for? Or like, what's the value of adding a bedroom to a house? Something like that. You would be able to interpret saying, okay, every one new bedroom, my house value goes up by like $10,000, for example. So yeah, good to just check that your coefficients make sense. Sometimes you see coefficients that you don't make sense. Like for example, let's say the coefficient for a number of bathrooms might be negative. Like every one new bathroom, does your price go down? Or maybe you have other ways that you can think about it. We shall see. But yeah, always good to keep track of your coefficients in case you're seeing anything that's like weird and not what you expect. All right. Now for like 1 to 2 intermediate points, it's a good thing to just check for your other linear regression assumptions. So earlier during your EDA, you can check for linearity and multicollinearity. But the QQ plot and residual plot, which is the heteroscedasticity check, as well as the heteroscedasticity check, as well as the normality check, these you check after you model. So good idea to check for those after your modeling at maybe 1 to 2 intermediate points. You also definitely want to see this for whatever your final model ends up being. Okay. At the end, I would say test with your test set to check for overfitting. This we talked about briefly yesterday. Over the office hours, I'll be talking through these processes again, because I feel like we didn't spend enough time just thinking about what this train test split is all about. So over the office hours, we'll talk about more of that. But yes, test with your test set and perhaps write a function that, because during your process of iterative modeling, maybe you choose to only use out of 20 variables, maybe you're only using 7, and perhaps you're doing different transformations and scaling to your variables. You want to incorporate that as well on your test set. So therefore, perhaps write a function that only selects the features you end up using and does the scaling for you, so that you can turn your test set to look like your train set. So yeah, if you culled your features, make sure you do the same for your test set. The number of inputs must match the number of features your model was trained on, and the order of your features matters. So if at any point between your train and test set, the order of your features change, you have to make sure that that's right. If not, the results will be off. All right. And also, yeah, as I mentioned, scale your test set based on your train set parameters. If you decided to min-max scale your train set, you have to rescale your test set with the min and max of your train set as well. So things to keep in mind and remember. Again, like anything that has to do with data leakage and train test set, I won't be nitpicky, but during your review, I might point it out just in case, so that you all know for the future. And finally, run cross-validation. And cross-validation is something I'm going to talk about tomorrow as well, so not to worry for now. So after the iterative modeling process, which is going to be the bulk of this project, you're going to decide on a final model, where you have to interpret your R-squared, interpret some coefficients, look at your RMSE, check out your assumption graphs, so on and so forth. And with that, that will be your final model. And that's what you can use to make predictions on anything else. As a bonus, things that you can do, you can create a prediction function. I'm going to walk through that process during an office hour as well. Scikit-learn has that .predict function. I sort of showed it yesterday, but not for brand new data. And basically, you need an array of inputs matching the features that your final model is trained on. I'll talk about that next week. So in this project notebook, you should end with your recommendations and future work, which is also going to be in your PowerPoint slide. So might as well just have it here too, just so that people who are coming across your notebook don't have to look at different places. So take a look at put your recommendations and future work at the very end of your notebook, as well as some conclusions. So your recommendations should lead back to your why and your business case, and if you learned anything from this model. Finally, I personally like to always have like an appendix or archives at the very end of my notebook. And this is basically for any like intermediate modeling that I don't think is very significant, but I like to keep. I'm kind of like a code hoarder. And so like any model that like, let's say I tweaked one small thing, but I didn't end up using it, but just in case I need to use it in the future, I like to keep that output at the bottom. So what I usually do is I take those cells, move it all the way to the bottom under this appendix section, just so I save all my output. So if one day I'm thinking, oh, what was that model that I ran like yesterday that I forgot? Instead of having to like recreate it, it's all in one place. So that's something that I like to do. That's optional as well. Okay, so that is the entire structure of this project. I would say for working in pairs, which most of you are doing, for working in pairs, the hard part, or I guess the strategy for working in pairs that tends to work best based on like what my former students have given feedback on, are because there's so many different strategies that you're trying for linear regression, good to divide and conquer. To say, okay, I'm going to look at maybe transforming features to see if it improves my model. Maybe the other person looks at dropping p-values or feature engineering some stuff. So yeah, I would say if you're trying different things, a lot of it won't really overlap, and then you can come together and see how it goes. Figure out which one the best model is. Cool. Now, any questions at this point?
Yeah, so the final model has to have 10 columns, correct?
No, not necessarily. The starting data has to have 10 columns, but if you find that out of the 10 columns, really only like 4 or 5 are useful for your model, that's okay.
Okay, and then whenever you're doing your plots, do you plot everything on this? Do you plot all of the regressions on the same graph, or would you use a different plot for each?
I would do a different one for each. Yeah, I would do a different one for each.
Okay.
Especially because like, and in terms of plot, in terms of regression results, really the only things that you can plot are like the normality checks, like your QQ plots, your residual plots, maybe even like your model output. You can't really do like the regression line on the scatter plot when you have more than one feature. So because of that, yeah, you probably will not plot multiple model results in one single place.
And then we structure our presentation around that final model, basically.
Yeah, that's correct. Yep, that's right. I'll be spending one of the office hours just talking about presentation. So this is actually the first project that y'all are doing that stretches pretty much the entire data science process. So the presentation is going to be structured slightly different from what we did last time, where last time was really just like, here are our insights. I mean, yeah, I'll talk about presentations and like things to include and what is useful to talk about sometime next week.
Thank you.
You're welcome. Cool. Anything else? I'm trying to think if there's anything that's good to mention as well. Ooh, okay. In your phase 2 content, and let me just click into student view real quick. In the phase 2 content, there is actually an appendix item that is a complete multiple regression project. And this is done on, I think, a completely different data set. I think it's about like Legos or something. But yeah, if you want to just see an example of how a multiple regression project is done, feel free to look through this. It's in the appendix, so I don't expect you all to like work through it, but would be good to just take a look and see what processes they're using. Maybe you can get some ideas of things that they're trying out. So yeah, just in case you want like a project to refer to, the solutions in here are a decent guideline. I don't remember, I haven't seen it in a while, but I think they should be pretty good. Nice. Any other question? Any other questions? So the first blog, try and get it done this week. For those of you who transferred into this cohort, don't forget to, if you can, just submit your first blog on the phase 1 link here as well. The direct link is right here. So you'll be able to click in there and submit your first blog from last time. The phase 2 blog will just be due before the next project. Cool. One more thing that I keep forgetting to mention is Monday is actually off. Monday is a holiday in lieu of 4th of July. So we don't usually meet on Monday anyways, but just in case you're wondering why is no one replying your Slack messages, because Monday is also off. I'll remind y'all tomorrow again as well. All right, if there is nothing else, I will talk to y'all tomorrow. We'll finish out our phase 2, which I feel like it's been like no time at all. But we'll finish out our phase 2 tomorrow. And yeah, any project questions or any questions at all, concerns, you all know that you can Slack me and let me know. All right, have a great day, everybody. Bye.